I'm going to fill in some gaps in our discussion of inflation, the consumer price index, etc. Okay? Now, does anyone recall the formula to convert a nominal value into a real value? If I gave you a certain nominal dollar sum, what would I need to do to it? Let's say this is a nominal dollar sum from the year T. Right? And I want to convert this nominal dollar sum, which of course is in year T dollars. I want to convert this into real dollars. And what are real dollars again? What date do I put below the dollar sign there? The base, yeah, exactly. And how do I do this conversion? Someone recall? Well, we would take the nominal dollar sum and we'd multiply that by a certain fraction. Correct? What is that fraction? It's always 100 in the numerator slot, 100 being the value of the consumer price index for the base year. And then in the denominator slot, we would put in the value of the consumer price index for year T being the year from which the nominal dollar sum comes, right? Now, we are going to use this idea to discuss now something called the real interest rate. Okay? And here's the story. Let's say that you go to, or rather you went to the bank a year ago and you deposited $100 at, let's say, 5% interest. In other words, you put this money into a savings account which was paying 5% interest. Clearly, this is not the United States because currently our interest rates are abysmally low, as you may be aware, right? If you put your money in IBC savings, for instance, you get 0.5% if you're lucky these days. But let's say that that's our interest rate, 5%. So you put your money in the bank last year, a year ago, at 5% interest. Can somebody tell me what this money is going to grow into today, a year from when you made the deposit, in other words? Any ideas? How much do you get back at the end of a year? Well, you get back the principal, of course, and you get back the interest, right? So what is the principal again? The principal is the original 100, and the interest would be 5% of 100. And how do you calculate 5% of something? That would be 5 by 100. The of simply becomes a multiplication sign. So basically, it's 5 by 100 times 100. The of is really just a multiplication sign there. Right? Now, I'm going back to really elementary math that you should have, become an expert at in middle school or something. Okay? Now, you cancel these 200s out, and you're left with $5 of interest. So what do you get back at the end of a year then? You get back $105. Is that right? However, bear in mind that the money you deposited was, what kind of dollar was that? That was last year's money, correct? So I'm going to put T minus 1, T being the present year. And today's money, the money 105 that you got back was in T dollars, correct? So you basically deposited one kind of money and you got back another. Am I making sense to you here? Right? Now, let's do something here. Let's convert this. Let's convert the money that you got back into the money you deposited. In other words, in order to facilitate comparison, let us convert the money that you got back, the $105 of today's money, let's convert that into last year's money, the kind of money that you deposited. Okay? That way we'd be able to figure out what your real interest was, because we'd be able to convert the 105 into something else. You follow me? How do you do this conversion? Remember, we are now taking the $105 not all the way back to base year. We're taking it back just 1 year. Right? Now, in order to do this, you're going to need the CPI values for these 2 years, correct? But let's say that I give you the following information. I don't give you the CPI values. All I tell you is there has been 2% inflation between last year and this year. This is the information I give you. Can you use this information to actually do that conversion, converting the $105 of this year into last year's money? How would you proceed? All I've said is that there is 2%, there has been 2% inflation between last year and this year. Right? Okay. The way to proceed is this. Let us consider, let year t minus 1 be the base year. Let's assume that that's true. We can set any year as base year. So let year t minus 1 be the base year. Now this, of course, would imply that the value of the CPI for the year t minus 1, that is last year, was how much? How much is that going to be? 100, exactly. 100 by definition, because the value of the CPI for the base year is always 100. Right? Can you, using this information, could you also perhaps figure out what the CPI this year is equal to? Exactly, it has to be 102. How do I know it's 102? Because inflation between the 2 years is 2%. And we know that inflation is nothing but the percent change in the value of the CPI. Isn't that right? That's how we calculate percent inflation. It's the percent change in the value of the CPI, right? So we know that's 102. So we have worked out the 2 CPIs that we need to perform that conversion, correct? Are you all with me here? So let's do that conversion then. So we take these $105 here and we multiply by what? We multiply by 100 on top, correct? What? Now remember, we're taking it back 1 year, but last year happens to be the base year. So we are, in fact, converting nominal to real, correct? And the way to do this is 100 divided by, somebody tell me what I should put in the denominator position? 102, the value of the CPI for year t being the year from which the 105 nominal dollars comes. Right? Can somebody tell me what this is equal to? $102.94. And what date do I put below the dollar sign here? What date do I put below this dollar sign here? Well, it should be base year dollars, correct? Right? It should be BY, right? But base year happens to be last year. So I'm just going to put, is that right? So by this story then, how much money did you deposit last year? You deposited this amount last year. How much did you get back this year in terms of last year's money? In terms of the money that you deposited. Correct? Now, given these two, could we calculate what's called the real interest rate that you have earned? What's the real interest rate that you have earned? How much? 2.94%, precisely. 2.94% is the real interest that you have earned because your $100 has turned into $102.94. And that is only possible if the interest were 2.94%. So that's your real interest. Am I understood here? So what was the 5%? What we call the 5% interest that the bank paid you? We call that nominal interest. We call that nominal interest. Whereas real interest is less. It's 2.94. Now you'll observe that 2.94 is pretty close to 3. Now you see what I did there? I made a funny equal sign. It's like a tilde and then like that. And that means approximately equal to. Right? So 2.94 is approximately equal to 3%. And guess what 3% is? 3% is the 5% nominal interest minus, guess what? The 2% inflation. Right? So we have a formula now for real interest. And the formula is real interest. I'm going to use the lowercase letter r to indicate interest. Real interest is equal to, or approximately equal to, nominal interest minus the rate of inflation. Okay, so this here is another important formula there. Real interest equals nominal interest minus the rate of inflation. Now, what is, let's apply this to real life, okay? What is the rate of inflation at present? What is the current rate of inflation? Now, all of you have smartphones that you use to, socialize, I suppose. Let's put it to some academic use now. Let's pull those things out and find me the current rate of inflation. Google that up for me if you don't mind. What is our US rate of inflation at present? Point 0.8% is what he's got. Does anybody have something? Can somebody else confirm that? So inflation is currently running at 0.8%. That, by the way, is quite low. Typically, US inflation runs at about 2%. In fact, 2% is the Federal Reserve Bank's target. The Fed starts getting worried if inflation exceeds, say, about 2%. Now, that is a very low rate of inflation. And why is it so low, do you think? I'm digressing a little here, but why is inflation currently running at 0.8%? Meaning cost of living is going up only 0.8% every year. Why is this rate of inflation so low? Can somebody perhaps think of oil prices? See, the fall in oil prices has something to do with it. Because when oil prices fall, energy costs fall, and energy is an input in really everything. Right? So when energy costs fall, it brings down the rate of inflation overall. Even the fruit and veg you buy at HEB, the price of that depends on the price of oil, in a sense. Correct? Because transportation costs come in, etc. Right? Also, the farmer's cost of producing that fruit and veg depends on the cost of diesel fuel that goes into his tractor, etc. Right? So that's our current rate of inflation. Now, can somebody also look at what interest a savings account will pay you these days? Interest on a savings account in a bank can give me, there will be some variation here, of course. Some banks will pay more than others, but give me a figure here to work with. Anyone have a figure yet? I'm guessing something like 0.5%, maybe less. Point? 0.06 annual percent. That's 0.6%. Oh, 0.06%. That's a bit too low, I think. Anybody have a figure here? 0.1? Okay. 0.1, that's 0.1%. That's the kind of interest you get these days with the low rates of interest we have in our country at present. Given these numbers here, could you calculate the real interest? What is the real interest rate? Now this 0.1%, what kind of interest is that? What the bank pays you. Is that real or nominal? That's nominal. You see? So if you put $1,000 into the bank today, you will get back, how much will you get back? $1,001 at the end of the year at that rate of interest. Right? But the money you put in was $1,000. The money you got back was a different kind of dollar. Right? So this is a nominal interest rate. So what is the real interest rate given these numbers? We know that the real interest rate is equal to the nominal interest rate minus the rate of inflation. So what would that be then? 0.1 minus 0.8, which is minus 0.7%. Now, is that a number that causes you to raise your eyebrows then? Minus 0.7%. What does that mean? That means that if you put your money in a bank account, a savings bank account, the money actually shrinks. Isn't that what that negative interest rate tells us? So in real terms, your money is actually shrinking when you put it into a bank today. Correct? So you may now ask, why do people then put their money in a savings account if it's going to shrink? What is your answer to that? I have money lying in my savings account, even though it's shrinking. Any thoughts? Pardon me? No, I don't think we're as ignorant. The purpose of this course is to make you less ignorant, right? So at the end of this course, will you then take your money out of savings because you now know that it's shrinking? Well, let's consider the alternative. And the alternative is to put the money under your mattress, the way your great-grandfather used to do, perhaps. Right? People back then didn't trust banks very often. What would happen to the money then? You would stick it under your mattress. You know, that's a form of saving also. Right? As opposed to entrusting it to a bank, you keep it in cash form. You stuff it inside your mattress or under your mattress. What happens to the money then? Does it grow? Does it shrink? You're shaking your head when I asked you, is it shrinking? It is shrinking. In real terms, it is shrinking. Because every year you have inflation. You have inflation, which reduces the purchasing power of every one of those dollars. Is that correct? So in real terms, what's the shrinkage that's taking place every year? Well, if you put your money under a mattress, what's your nominal interest rate? Right? What's the inflation rate? The same 0.8%. So what would be your real interest? 0 minus, which would be? So in other words, your money would lose the full value of inflation. It would shrink in real terms by 0.8% every year. On the other hand, when you put it into savings, it shrinks all right, but it shrinks by less. Do you see that? It shrinks by less. Hence, it makes sense to put it in savings, even though it's shrinking. Am I understood here? So if you were an investor, right? Some of you may be finance majors, and in that course you will learn how to perhaps manage money of yours and other people's. As a person who is, say, managing your own funds or somebody else's investments, financial investments, what is your target going to be? You're going to have to beat something in order for the money to grow in real terms. You have to beat the inflation rate, exactly. So you have to invest your money in such a way that your rate of return on that investment exceeds the current rate of inflation. Because if it doesn't, then your invested funds will not be growing in real terms. And real is what's important to you, not nominal. Correct? Because real takes into account the changing purchasing power of the dollar. And you are finally interested not in the money itself, which is just a pile of paper. You're interested in what you can do with that money, what you can buy with it. Correct? So you're always interested in real sums rather than nominal sums. Right? And so in order for your investment to grow, you have to beat the rate of inflation, which currently is 0.8%, but usually is about 2%, even more than 2% occasionally. Okay? All right. Now we come to a discussion of something called the real wage. So we know what the real interest rate now is, and we will now discuss what the real wage rate is. Let's say that you get paid a certain sum of money. Let's say your hourly wage is $10 an hour. This is what you're getting paid today. Would you call that a nominal dollar or a real dollar? What date do I have below that dollar sign? Correct? I don't have base year there. I have 2015. So this is here. This here is a nominal wage. How do I go about converting this into a real wage? You see, it's possible that this is what you earned this year. And let's say last year your salary was, or let's not go last year, let's go to 5 years ago. Let's assume that you were working back then, 5 years ago. 2010. And let's say back then your salary was 7 an hour. This too is a nominal wage. Now, could you say, sitting on your armchair one evening, could you perhaps derive a sense of satisfaction from this? Here's my question. I'm doing better now than I was 5 years ago. Could you say that with confidence? Do you see what I'm saying? A lot of people actually delude themselves into thinking, yes, they are doing better off because now they're making $10 an hour, as opposed to $7 an hour 5 years ago. Am I correct? Lots of people will say, well, they're doing better. But we now know, as budding economists, we know that that logic is wrong. Correct? In order to actually verify, to say with confidence that one is doing better off, one is doing better, one has to do what? One has to convert both of these into real dollars. We need to convert these into real dollars. And for that, we need the values of the consumer price index. Now, could we, once again, pull out our smartphones and look for the Bureau of Labor Statistics consumer price index figures? Somebody quickly tell me what the values of the CPI are. We have a figure for 2014, which is the best we can do. December 2014. What was that number again? 234.812. And what is our figure for 2010? 218.056. Okay, so we have our two CPI values. Okay, let's do our real wage conversion now. Let's do our real wage conversion. So what do we do here? What is this number here going to become? $10. The $10 is going to become 10 times 100 on top divided by $234.812. And this is going to be, of course, in base year dollars. The other one is going to become 7 times 100 divided by 218.056. Could you tell me what these numbers are? Anyone have the calculation done? You're all following me, I suppose. We're simply applying a formula that converts nominal into real. 4.26. Can you give me one more decimal just in case?
3.
Okay, the other one. How much? Is that correct? Okay, so can you now say with confidence that your real wage has increased? Yes, it has increased by about $1. Right. Now this kind of calculation is exceedingly important, from a practical point of view. Because you may, for instance, have bought a house. Let's say you bought a house in 2010 and you paid $125,000 for it. And this was 2010 money. And last year, in December, you sold the house for $135,000. This was 2014 money. And you think, I've made a $10,000 profit. Lots of people think like that, Correct? But that, of course, is wrong. Right? How would you figure out the actual profit? Well, you'd have to convert both into real dollars. How about doing this? Instead of converting both into real dollars, how about converting this into 2010 money? Could you do that? If you had the CPI value for 2010, which you do here, and you have the CPI value for 2014, could you work with these numbers to convert the $135,000 into the kind of money you paid for the home, which was 2010 money? How would you do that? Any thoughts? Now we're not converting the base year, because base year is all the way back to 1982 to 84, right? So we're not taking it all the way back to 1982 to 84. We're just taking it back to 2010. Now let me give you a quick way to do this. When you take money back in time, the money has to shrink, correct? Now, how do you make something shrink? Mathematically, you can make something shrink by multiplying it by a fraction smaller than 1. Right? When you multiply a number by a number smaller than 1, you get as your answer a number that's smaller than your original number. Right? So you're going to take this 135,000, and you're going to multiply it by a fraction smaller than 1. And the numerator and denominator of this fraction come from the values of the CPI for the 2 concerned years. Now, in the case of our conversion to base year, we always had 100 in the top slot, correct? And what is 100? It's a CPI for the base year itself. So always, in the numerator and denominator slots, we're going to have to put the values of the CPIs of the 2 concerned years. Right? So which one of these am I going to put? Which one of these am I going to put in the denominator slot? Which one in the numerator slot? Now remember, I want this fraction to be smaller than 1. I want it to be smaller than 1 because then when I multiply the 135,000 by that number, I get something smaller than 135,000, which is what I need when I take money back in time. Am I understood here? When I take money back in time, the money has to shrink, right? Is that understood? It has to shrink because back then a dollar could buy much more than today, see? So money today is worth less in terms of money in the past, so it has to shrink. So which one do I put in the top slot and the numerator slot, which one in the denominator slot? I'm going to, of course, have to put CPI 2010 in the numerator slot and CPI 2014 in the denominator slot. Why? Because this number here is smaller than that number. 218 is smaller than 234. I have to put the smaller number in the numerator slot in order to get a number, in order to get a fraction less than 1. Am I making sense here to you? This is a mechanical way without, you can do this without much thinking. So what does that 135,000 become then in terms of 2010 money? Let's use our two CPI values here to do this. 135,000 times 218.056 divided by 234.812. What is that here? $125,703.77. This is in terms of 2010 money. So have you made a profit? Yes, you made a $703.77 profit. It's not a loss, but it's a very tiny profit. Correct? So this is how one can convert nominal into real. And if I had those CPI tables on hand, I could have done something more interesting. I could have shown you what a car, for instance, the first mass-produced car in the States. Does anyone know the name of the first mass-produced automobile in the US? Oh, yes, exactly right. T model Ford. Ford Model T. Right? And we could have converted that into today's money. Okay, let's see if we can do this. And if I can't, maybe perhaps you can find these CPI numbers from the past. Okay, but before I do that, I'm going to have to do a little search here. Right, and we want what the car cost in the past. You see the pictures of it already, right? Price and production. So here we have prices. And you see here, in 1909, the car was actually more expensive. It began to fall. By 1914, it was costing $440. By 1915, it fell even further. By 1916, it fell to $345. It's been going down, the price of Model T Ford. Why do you think that was happening? Digression. How was Henry Ford, able to sell his car at a cheaper and cheaper price as time went by? Because? No, because he became more and more efficient. He could do things more cheaply. You see, remember, he was the first guy who, instead of getting the worker to the job, he brought the work to the worker on a conveyor belt. Am I correct? So in his production line, you had one worker doing just one job, right? One guy's job maybe was perhaps to fit the windshield wiper, and that's all he did. The car came to him on a trolley, on a belt, right? And all he did was that one thing. Of course, since he did it so often, all day, he became really good at it. Correct? So Ford could enjoy all these great efficiency gains because of this innovation. And any gains in efficiency, of course, translates to a lower cost of production, right? Hence, he was able to sell his cars at that low rate. So that car cost in 1916 $345. Then it went up during those years, and perhaps it went up because those were the war years, the First World War, right? And during the war, raw materials become more expensive because a lot's being diverted to the war effort, right? And then after the war, again, the price falls to about $395. I actually did this conversion in one of my earlier classes. I took this model, this price of say about $400, and I converted it into today's money. And guess what it came to? I don't have the numbers, the CPI figures to do this here. I would have liked to, but let me tell you what that converted into. It converted into something like $11,000 in today's money. $11,000 in today's money. Now you tell me, is that a cheap car? Let's look at the specs of this car, okay? You see what it looks like, correct? Very rudimentary. This was a 2.9 liter engine producing 20 horsepower of energy. 20 horsepower. Do you know what your average car gives you these days? Certainly in excess of 100 horsepower, 150 maybe if it's a small car, right? So this is a very weak engine by today's standards, right? Top speed, 40 to 45 miles an hour. That's your top speed. So you'll be tooling along at about 30 miles an hour generally. Fuel economy of 13 to 21 miles a gallon. $13 miles a gallon and you're going at 30 miles an hour. It's not a very fuel efficient car, correct? Did it have any safety features? I don't see any safety belts or anything. In fact, it's well known that if you had a crash with a Model T Ford, you pretty much got impaled on the steering shaft. And you were paying how much for it again? In today's money? $11,000 for it. So clearly, when your grandfather tells you that things were cheaper in the past, more expensive now, and you can give him the example of the Model T Ford. That was a very expensive car for the kind of car it was, right? For $10,000 today, you can go and buy a very respectable second-hand car. Am I correct? That's way better than this Model T Ford. And that's all the time I have for today. We'll review again in our next class, okay?